we're going to take a couple steps back. We'll presume that we've run our initial analysis and we want to make some design modifications to improve the flow distribution into the cold fluid domain, as well as how the hot fluid exits out the bottom plenum. So the two plenum changes that I alluded to at the start of this training exercise. The first one we'll focus on will be the hot outlet plenum. I'm going to make a new section and I'm going to put it in between the hex core and fluid generation and the CAD and implicit references. So I'll add a section underneath here. I'm going to call this additional plenum creation, and then :C sections below. The reason for this is I want to create multiple different plenums and have them in their own discrete sections. So I'll create one more, add section, and I'll call this oil outlet plenum. At this point, I've already conceptualized on the shape of the plenum that I want to create. And if we look closely at the cross-section of just this fluid domain here, and as we come into this exit, we'll see that we're only really, all of the oil is really only exiting through these two passageways out of the hex core. So we want to increase the amount of flow area, and we want to make it self-supporting at the same time. The general shape that I am going to create is roughly going to be just a simple cone that allows the fluid to flow in and out through the exit pipe. At this point, we're going to get a little bit in the weeds as far as referencing different CAD entities, tying the implicit geometry to those entities to make the entire system a bit more parametric, so that if our oil inlet pipe diameter changes, the plenum that we're about to create will automatically change with that. I'm going to minimize the two sections here at the bottom. I'm going to go ahead and open up the CAD and implicit entities, CAD and implicit references. And I'm going to call on the cardinal face points block. So I'll start to type cardinal, and I'll get the custom block that's cardinal face points. I'm going to make this a variable, and the input body in this case is going to be my outlet pipe, my oil outlet pipe. All this block does is it goes to the bounding box and captures the centroid at one of those faces of the bounding box. So I always start with 0, and in this case we can see that it put the point here at the bottom, but I'm looking for the point at the top of this oil outlet pipe. So I'll put 1, and that point pops up to the top. I'm going to rename this to oil outlet pipe top point. The other piece of information that I want to reference relates to the radius or diameter of this outlet pipe. So I'm going to isolate just the CAD body. I'll turn off the cross section, and I'm going to call the custom block radius of CAD cylinder or hole. We'll drag this to the CAD and implicit region, and the input here is going to be a CAD edge list. So I'll select the edges that I want to capture the radius of, right click, create CAD edge list, and I'm going to call this oil outlet ID edge. We can't put a list in a list, so I'm going to remove the list from this custom block. I'll drag this into here, rearrange these to a chronological order just for my own sake, and then I'm going to call this oil outlet radius. We'll put inner radius. So come down to the oil outlet plenum section. Under the Create tab at the top, I'm going to select cone, or you can search for it in the search blocks window. I know I'm going to want point 2 to be at the top of this oil outlet pipe. So I can drag and drop the point that we've created from this cardinal face points block into here. So now it's tied to that geometry, and the cone has disappeared. The reason being is both these points are both at 0, 0, 0. So if I was to just randomly increase this value up to 10, we'll see that that cone gets inverted. I want point 2, or this bottom radius now, to be tied to the radius of the outlet pipe. So we'll go ahead and define that. And I'm going to make this radius a variable. And we'll just name it top radius for now. Next thing we want to do is I want to make the point 1, or the top of this cone, a handful of variables. We'll start this process by just typing point into one of the inputs, select point. Now we want the, in this case, if we look at our axes, the x and y, we want to always be the same, which is going to reference this oil outlet pipe top point. So we can come under the properties section of this point and capture the x and y values of this point. Then we're going to do an addition. So we'll type add into the z value. We'll get the z of the center of this CAD body, and we'll make this a variable. So I'm going to make this a variable, and I'm going to call this plenum height. And more specifically, we'll call this oil outlet plenum height. And we can call this oil outlet top radius as well. And we'll go ahead and put a value of, I don't know, 1 inch, let's say. We can type 1 and IN to get a value of 1 inch. So we've created our initial funnel for this object. Next thing we'll do is we want to, let's say, round the top. The quickest way I find to do that is we'll use our sphere. The center point is now going to be the top point of this section, which is this point 0 that we've created here. And we want to tie the radius of the sphere to the top radius of our cone. So this will be the input radius for our sphere. So that way, if one changes, they'll both change. The next couple things I want to touch on are manufacturability, as well as the flow area exiting the hex core for specifically the hot fluid. So I'm going to turn on the infill volume quickly, and we'll look at a cross section. So in this case, we could infinitely, let's say we want to have the plenum reach 5 inches in. It's just going to continue to extend up, and we would change our design space or our infill volume to mimic this. In reality though, the outlet plenum for this oil doesn't need to be this large. So what we can do to try and figure out how large it needs to be is evaluate its exit surface area. In order to do that, we're going to union together these two segments. So we'll make these variables first, and I'm going to call this one oil outlet plenum, OO plenum, segment 1. And the second one I'll call oil outlet plenum segment 2. I'm going to call on a Boolean union block from the search tab. Pull these in together. Make this a variable. And I'm going to call this raw hot outlet plenum. We'll isolate just this. So what we can do pretty quickly is we're just going to use a mesh from implicit body block, drag and drop the implicit into here, choose a tolerance value, and we'll define that we want sharp edges. Next thing I'm going to do is I'll right click on here and I'm going to say filter mesh by flood fill. And if we look at just this filtered mesh, I'm going to isolate that. We've in fact captured just the top half of the cone, or the top section of the cone. Might capture a little bit more, so we would turn this to 40 to ensure that we're only capturing this section. Then what I can do is surface area for mesh, drag this into here, and see that I have an exit area of 700 millimeters squared. We'll divide this by 2. So there's a couple ways that we can call this block. We can do search for divide in here. We can go to the top of the ribbon and select math. Or a newer feature is the context search. I can select in context search. It's going to auto filter all of the options that this block can get nested into. I'll search for divide. I'll pop that into here. And I'm going to put an operand of 2. I'm putting an operand of 2 because half of this area, at least, is going to be consumed by the baffles that we create to keep the fluids from mixing. So as long as this now exit surface area is greater than or equal to the flow area that's coming out of the outlet pipe, then I'm good. So we can quickly evaluate that. You might already know it from your calculations beforehand. And in this case, the value is about 126.5 millimeters squared. So as long as I have this value, larger than this, then I'm not going to choke my flow upon exiting. So what I can do now is, if I turn the infill volume back on and look at a cross section, we're ultimately going to do a Boolean subtract of this body from our infill volume. So we're removing surface area, working surface area. So we don't need it to be this large. We can start to decrease this height value, let's say, until we've hit our target value or gotten pretty close to it. In this case, I'll just stop at 0.75 inches. Next aspect I want to quickly look at is manufacturability. We can call upon the angle field block. So I'll look for angle field block in the search blocks window, and I'll drag that below the raw hot outlet plenum. I'll drag this into here. I'll make this a variable, and I'm going to call this oil outlet angle eval. So I'm going to isolate just the hot plenum, and I'm going to click F to look at the field of this block, and I'm going to change the plane to normal, and I'm going to turn the color map onto turbo. Now initially this is pretty difficult to read. We can click the probe values and move around and kind of see what the overhang angles are going to be. What we can do to make this a bit more readable is we'll enable the custom range, and we'll take our min value from 0 to 45 degrees. And I like to turn the contour intervals on to 15. So every line we see here is a 15-degree interval. So we can zoom in now and start to probe around. And at this point, at this line and over here, we have our 45-degree or less angles. So we can do a quick evaluation. We might know that we can have an acceptable overhang, let's say, of less than 3 millimeters. So we can stick with the top radius that we have. Perhaps this was set to 4, and we look at where we have our 45-degree angle now, and our overhang is from about 0 millimeters out to about 5.6. So we'd want to potentially start to decrease this radius until we've met this overhang constraint. And while we've increased this radius, we've also increased the exit surface area. So I'll take this back to 2. So that's a quick and dirty way to both evaluate the printability of the plenum we're about to create, as well as evaluate the exit flow area for the oil. I'm going to close the field viewer. We can leave these blocks here if we'd like to, or we can go ahead and delete them. I'll leave the blocks here for now. The last step is going to be unioning the raw fluid plenum to our exit oil outlet fluid. So under modeling, we'll select Boolean union. Our raw outlet plenum will union to the oil outlet fluid. Make this a variable, and I'm going to call this hot outlet plenum. If we want, we can also put a dash final so we don't get confused later on. And now all we have to do is incorporate this into the design. So our design space in this case is our infill volume without that new plenum volume. So we'll remove this infill volume. I'm going to type in union into here, capture Boolean, oops, not union, excuse me, subtract. Find the Boolean subtract, and our primary body is going to be the infill implicit, and we're going to subtract out this new hot outlet plenum. Now the entire workflow that we just created is going to rerun. So if we come to our final outlet fluid and visualize this hot section and look at the cross section of it, we've now removed that body, but we don't have that fluid attached. So what we would do is come to our final hot fluid, and rather than this oil outlet fluid, we're going to capture the hot outlet plenum that we used to subtract from that design space. We'll pull this into here. Now that gets updated. The next aspect is going to be the baffle generation. It's going to be the hot outlet baffle we'll want to update. So rather than this oil outlet fluid, we'll remove that and put in our hot outlet plenum. And updating those 3 components, we've now fully updated and automated this process. So now we can continue the iterative process of maybe sending it to real-time sim and evaluating the performance. The same would be true for evaluating cell size, or maybe we want to look at the diamond structure and see how that behaves. It's all now linked together and everything is going to update accordingly and as needed. We'll hit Control Z.